All right, there's the answers from yesterday. You can check those if you care to. I'll scroll down to the next set here. ACP problem, hopefully. I didn't look at it this morning. What was it? Something we could do for a change?
Yes.
Was it? Oh, good. Domain range, we were working on that last night. And remember, domain is our input and our X values, range is our output. Today, we're going to do a little bit of stuff with function notation. Today's pretty similar to yesterday. Lots of stuff to review from Algebra 1, just some terminology, and, you know, it should be pretty straight up. We're gonna go pretty quickly through it. Take whatever notes you want, and put that up right there. Move on from there, see if you're looking at any of those homework problems. Just gonna change one thing today. I'm gonna have you close your computers as we go through the lesson, so you're not gonna be able to follow along with that today, so I'm sorry about that. So you will be asked to close your computers down today. Or what is the word that some of the,
Professional course.
there you go, that's it, right? So, finish up whatever you're doing there and then cut those lips. Thank you so much. All right, so a couple things there, domain range, function. On the assessment on Wednesday, the test, I'm not gonna hit this real hard. There might be a question where you have to list the domain and the range, but it should be pretty straight up for most of you. So I think you'll be all right. All right. Today, I'm not gonna hit these warm-up problems. I think we'll be all right. Let's get right to what we're gonna learn today. We got 3 things to talk about today, 3 things before you leave. And I think if I were to give you the homework right now, you could probably do it. That's how simple today is, okay? So number 1 is right here, okay? Number 1, we're going to write function using function notation. What does that mean? Well, that means instead of saying y equals 2x plus 3, we're gonna say f of x equals 2x plus 3, okay? You've used function notation in Algebra 1, didn't you? Nothing earth-shattering. You should realize that f of x and y can be interchanged. So f of x and y can be interchanged. They're really similar, aren't they? Okay, so function notation in that. The second thing we're going to do, evaluate. Okay, evaluate. So that would mean something. Evaluate means, what is f of 3? We're going to put 3 into this. So you'd say 2, but now x is going to be 3 plus 3. Of course, 2 times 3 is 6, plus 3 would be 9. So f of 3 equals 9, or it is the coordinate x at 3, y at 9, isn't it? Algebra 1 stuff, everybody, isn't it? Pretty straight up, nothing that's rocking us yet. Algebra 1 stuff. Skill 2. Skill 3 that we need to practice today, and that is right here. We're gonna graph. We're gonna graph that point. We're gonna graph some points, more than one point. Okay. So that's how you have it. What do you think of those 3 things? Am I right in assuming that I just tell you right now, do the homework, you probably do all right with me. Okay, so let's get through this and then we'll have some time and we can knock that out and submit before we even leave the room today. Sounds reasonable, everyone? And again, we're looking at a summative chapter 1 assessment on Wednesday. It's around 88 points, some points, so it's a good chunk. I'm giving you a practice on Monday, we'll review on Tuesday, you'll be ready, okay? Don't, just like the quiz, was the quiz very similar to the practice? And so with the test, okay? The goal is for everybody to get whatever grade they feel like getting. Hopefully that's a B or an A. So you just study a little bit, you'll be fine. Some of this we're gonna just skip through today, because it's not all that relevant. Here is evaluating. I just kind of went over this. There it is in function notation. Plug in f of 1, and we would have the coordinate 1, 8. Now, is there a limited number of coordinates we can find? No, unlimited, isn't it? You remember back in Algebra 1, they give you, make you make a little table, remember? You put in 1, 0, -1, or you'd start with 2, 1, 0, and you would get the output value, input, output, and then graph that. Okay, we are gonna do that here in a second, but that's all we're talking about here. How do we feel about finding an output value with this particular input? Does everybody feel okay about that? What if we wanted to find, let's go with f of 10. F of 10 of this, so now we're gonna have 5 times 10 plus 3, right? 53, so now that new point, or that coordinate would be 10, 53, wouldn't it? We can find an unlimited amount of those. Okay, I think that was skill 1, right? Is everybody good? What was the next one? Was it graph? No, graph was the last, was graph the last one? No. Evaluate, was that? Oh, what was the first one then?
What was that?
Oh, okay, evaluate.
I'm so confused.
I did too, let's go back and see what I asked.
Brain functions.
Right functions and, oh yeah, first was right functions and function notation. Everybody good there?
Yeah.
Number 2 was evaluate, that's what we just did, right? Are you still confused? All right, good, everybody good? What's the last thing? Okay, let's do it. So 1, function notation, 2, evaluate. Let's get to a graph. Not messing around this morning, hopefully that's okay with you. I'm not even gonna do this problem because it's pretty simple. Is everybody okay with evaluating? All right, let's get to a graph problem. Just take a quick second, draw yourself out a little Cartesian coordinate system. This is 7 going right here, of course, it got scooted down on me. And just grab those quick points, that's all. We're gonna graph those and we're gonna do one more graph after this. We're gonna do about 3 more things. One real graph where we gotta come up with the points. We're gonna write a couple of equations and be done. So I'm not graph paper is not a requirement. If you're a person who likes the graph paper, you might pick up a sheet or 2. I'm sure Amazon has it for a decent price. I do not have any. I know that there are some math teachers who require some graph paper, but not an important thing to me. So remember your x is your first value, so these are all in x, y. And of course, you have had plenty of graphs in your career, and I assume you're on your way to graphing this guy correctly, but I'll show you what it should look like. This is going to be a linear, should be some dots look like they form a straight line. And roughly in this area. So x is 0, y is 4, so x is 0. Y is 4 here. Of course, this would be x at 1, y at 5. This would be x at 2, y at 6, x at 3, y at 7, and finally, x at 4, y at 8. And that would be a linear, which we're gonna study next, after the start of next week, after we take our assessment on Wednesday. We'll be going into linears, MX plus B, which you should be able to do pretty well with also, a lot of logical one review. How do we feel about graphing now? Bless you. I want you to see if you can make a table. I only want you to make find 3 points to graph, okay? Now, when we make that table, a lot of times it's gonna look something like this. You might remember doing this back in good old Algebra 1. Okay, here's our x, and here's our f of x. And we always like to choose -1, 0, and 1. Those are easy numbers to calculate, right? And they're also really close to the origin. So when we graph it, it's a little easier. Okay, so now you're gonna evaluate. Evaluate -1, 0, and 1. And then see if you can just sketch a little graph of just those 3 points, okay? And then we have 2 more problems and we're done. Evaluate -1, plug him in. Plug in -1. Your x's are our independent value. Your y is dependent upon the x. So you have an independent and a dependent. The independent is something that changes. You change your x's, whatever you want to put in. Your y depends on what your x is, doesn't it? Let's see, -1 into there, what are we gonna get? -4? Did I get that right? Plug in 0, -1. Plug in 1, we're gonna get +2. How are my numbers? Are you okay with those? Everybody okay? Of course, you've already practiced graphing a couple numbers, so you could throw these down on the sheet, give you about 40 seconds here. Home game tonight, huh? Golf team beat McKinley last night, but that's not much for us. They're not very good in golf, as you can imagine. That's not their sports are basketball and football, and one they're pretty good at track, I think, too. We all have our sports that we're better at, it seems like. So again, that table, you can pretty much pick whatever you want. Your values can be, anything. But again, why did we pick those? Because they're really close to the origin, we can calculate them easy. And you really need 2, but for general purposes, we'll find 3 points. And then graph those 3 points. How we doing? Everybody good? Well, that was our skill 1, 2, and 3. I think we're done with that, but I want to show you 2 more problems. And that is writing a equation. So everybody feel okay about making a table? All right. I'm gonna ask you to maybe write an equation or 2. So we're gonna do 2 of these. And let's just read this problem. So the car will charge us $5 entrance fee and $2 per ride. Write a function that represents the total cost after taking a certain number of rides. So our function is quite simple. Cost is a function of what? How many rides I take. Okay, now what would be the equation for that? Well, we know there's a flat cost. What is the flat cost? Okay, so the flat cost is going to be 5 plus 2 times, okay, or we'll make it realistic, which would be for what? Right. Now, Am I gonna count off if you write it as X? Not at all. Okay? So we can abbreviate this and say cost as a function of R is equal to, now a lot of times, I won't count off if you don't, but a lot of times we'll put the 2R first because that's called standard form, isn't it? Okay. So cost is how many rides? If I do 0 rides, what's it gonna cost me to get in? $5. If I do 10 rides, how much am I gonna spend that day? Real simple, 25, huh? I know some of you are like, oh, okay, can I write it as f of x equals 2x plus 5? And what do you think my answer is to that? Yes, you can do that too. What is our independent variable? What's the input? Independent variable here is rides. So what does cost? Cost depends on how many rides I take, right? Makes sense. How's everybody feel about that? See what you can do with this one right here now. And we'll think about that one. We're gonna write one more. And we're gonna call it a day. Luke, how's that sound? If you haven't retake, today is the last day, or unless you make some special arrangements with you for next week. That retake of that first quiz, I would suggest definitely before Wednesday. Wednesday will be the last day for anyone. This one's a little different than that carnival one, isn't it? What's the difference in this one than the carnival one? There's no flat P, is there? Okay, there is no straight up flat P, so my cost is a function of the number of prints. Make sense? Cost is a function of the number of prints, and that's just gonna be 0.27 times my number of prints, isn't it? How we doing? Everybody okay? We did function notation, we did evaluate, and we did graph, and now we added this little guy right here, right? Those are the things for today. Does everybody feel comfortable? Of course, if we had 10 prints, okay, that's the ultimate. We're gonna plug it in the value. How much would it cost if we did 10 prints? Of course, that would, $2.70, right? Is that right? Everybody feel comfortable there? How about this one? And this is the last one. See if you can rank this one. It's another cost as a function of something. And we're done. So what is affecting our costs?
The amount of paints cans used.
Amount of cable, right? So cost. Now, can, we don't want to use CC there, right? Because that would might, so I'm going to use what? P. So cost is a function of P. That would be P. Of course, this is like getting into the carnival again, isn't it? We have a flat plus 25 times P. And again, you could write 200 first plus 25P. Most likely, we'll put the 25P plus 200, and that's just in standard form. Well, we accept that, of course, then we would ask you, what if we use 4 cans of paint? So what would we have before? Of course, we just plug in 4 and have 300, right? These are simple linear equations, aren't they? Linear. Lots of things are done with linear. Linears are everywhere, used quite often in the real world. Okay, we got a couple of skills we went over. Everybody feel comfortable? I'm going to eliminate some of these. Does that sound good to everybody? We're going to eliminate those. So we're going to eliminate this and just do 33 plus 318. How about that? And I do have that on Canvas already. So thank you so much. You guys are great today.